Hey everyone, am I audible? Can you quickly confirm if I'm audible? Then we'll get started. Let me have my iPad. Hello, am I audible? Can someone confirm on the chat? Yeah, it is. It is audible. So, how did you like? Audible नहीं हो क्या? कोई reply क्यों नहीं कर रहा है? Okay. No sound? Sound तो आ रहा है. ये no sound वाले झूठ नहीं बोलने का. तो शुरू करें. Clearly audible? Perfect. So, how did you like this surprise yesterday? Was it worth it? एक second. It was boom. Yeah. Absolutely loved the response, man. I think we have 60,000 views and it's not been 24 hours yet. So 60,000 views with, I think, 12,000 likes and 2,000 comments. That is massive. As massive. I think we already have a lot of traffic on the website because of that, and once the videos start coming on the beginners, I feel it's gonna go very very boom. हाँ मतलब for beginners it's an absolute treasure. मेरे बैचमेट्स मेरे को मैसेज कर रहे कि तुझे हमारा सीनियर होना चाहिए था. So बहुत दिनों बाद नहीं बहुत दिनों बाद नहीं यार. कल मैं स्ट्रीम करता बट वो कल पूरा वीडियो बनाया एडिट किया 3 दिन से सोया नहीं था तो मैं बोला कि आज करूँगा तो मेरी तबीयत खराब हो जाएगा. दैट इज़ व्हाई आई डिड नॉट डू इट. एनीवेज इज माय दिस विजिबल? Is my screen visible? Can you quickly confirm if my screen is visible? ठीक है, visible है, I guess. So yeah, we will be solving Job-A-Thon 12 hiring challenge problems. So let me just get everything ready until everyone joins in. We have everything ready. ठीक है. Perfect. ये भी ready हो गया अपन का. सुभान अल्लाह. बढ़िया. वेट कर रहा हूँ सब आ जाएंगे तो. कल करते तो ज्यादा लोग होते बट कोई बात नहीं. कोई बात नहीं, देख लेंगे. सब यूट्यूबर अपना अपना प्लेटफॉर्म क्यों खोल रहे हैं? आई थिंक सब अपना प्लेटफॉर्म नहीं खोल रहे हैं. तो देयर वाज दिस अन अकेडमी का है सारा. तो किसी का मतलब अपना प्लेटफॉर्म नहीं है. मोस्टली दे आल्सो रीच्ड आउट टू मी कि आप हमारे प्लेटफॉर्म पे कोर्स बनाओ. देन आई सेड कि नहीं भाई आपका नाम बहुत खराब है. तो बोलते हैं ठीक है हमारा नाम हटा दो, हम आपका बैकएंड से वेबसाइट वगैरह बना देंगे एंड कहीं हम लोग विजिबल नहीं होंगे. तो काफ़ी बड़ा गेम है बट कोई नहीं, शुरू करते हैं. चलो शुरू करते हैं. Make some even is the first question. How many of you were able to do this? How many of you were able to do this? Jobathon, I found the questions to be easier than the previous Jobathons. The question was pretty easy. Like if I would have given the test, I think I would have done it very fast. The questions were very easy compared to the previous one. How many of you were able to do this? Can you tell me how did you guys do this? So the question is pretty straightforward. Given an array of length n, Geek wants to split it in pairs such that each element should be in exactly one pair and the sum of each pair is even. So basically they'll give you n numbers and you have to split them into n by 2 pairs. So the question states, बहुत दिन बाद n numbers दिए होंगे and you have to split them into n by 2 pairs. So basically something like this, something like this, something like this, something like this. You have to split them into 2 pairs and the sum of them should be even. So can you tell me, how do I get even sum? How do I get sum to be even? It's very obvious that either odd plus odd has to be there in the pair, or even plus even has to be there in the pair in order to get the sum to be even. Does everyone agree with that? Either I have to pair up odd and odd to get an even sum, or either I have to pair up even and even to get an even sum. I cannot have something like an odd and even, because if I pair up odd and even, that will always give me an odd sum. So something I'm definitely sure is I have to pair up odd and odd, and I have to pair up even and even, right? So can I say that if I'm looking to pair up odd and odd, I need even number. I need even number of odd numbers. I need even number of odd numbers. Then only I can pair them. Then only I can pair them. Like if I have five odds, will I be able to pair them? I won't be, because I need exactly, because every pair will consist of two. So if I have five odds, I cannot split them into pairs. I cannot split them into pairs. So can I say the number of odds should be even? The number of evens should be even. If the number of odd and even are even, then I should be able to pair them up. I should be able to pair them up. Does everyone agree with this? If the number of odds or and the number of evens are even, then it is a yes. If any one of them is odd, then I say it is not possible to pair. Can I get an US if you understood the understood the approach? Can I get an US if you understood the approach? Can you guys give me an US if you understood the approach? Then I'll move forward to coding this. Perfect. Quite simple, right? बहुत ही simple था. I'm going to simple. So I can be like count odd equal to 0. Why do you need a map? Count even equal to 0. And then you can just go across the vector and you can say if id mod 2 is an odd, count odd, and yeah, count even will be nothing but array dot size minus count odd. And you know, if count odd is odd, or count even is coming out to be odd, then you return not possible, else you return a true. Simple as that, right? Perfect. Let me quickly submit this off. Should work. So I hope everyone has understood this, right? Everyone has understood this. Cool. Uh, let's move to the next question. Okay, here's the next question. How many of you were able to do this? How many of you were able to do this next question? How many of you were able to do this next question? So it's a very standard question. You have to just apply brute force and it will work. Please discuss in Java too. अब अगर तुम जावा में काउंट ऑड और काउंट इवन नहीं लिख सकते तो तुम पढ़ाई छोड़ दो. छोड़ दो कोडिंग भाई. लीव कोडिंग if you can't write a code to count odd and count even in Java. For that also, if you need my help, then I think you should leave coding. This is not for you. Sorry, service. That is, coding is not for you. Stop doing this. Do in Java, do in C++. Counting odd and counting even in Java or C++ or in Python or in JavaScript, that's the most basic program that you can do. The way that you write for loop in C++ is same in Java as well. The If you're using a stack in C++, it's the same in Java as well. If you're using a linked list, it's the same. क्या करूं मैं, कहाँ जाऊं? Okay, I mean, if you're able to do this. Subarray counting also, it's the same. Don't worry. There is no optimization. This will be brute force. This will be brute force. There will be no optimization. It's a plain brute force. There's a proof to it why brute force. There's a proof to it why brute force. So let's understand the question. So the question states, count the number of good subarrays of the given array. If the prefix GCD array has only distinct elements in it, then the array is said to be good. So an array prefix is said to be prefix GCD if this prefix, this is the prefix. So basically 15, 6, 19. Is it 15, 16, 19? Now, if I write the GCD of just 15, that is going to be 15. If I write the GCD of 15 and 16, that is going to be 3. If I write the GCD of 15, 6, and 19, then it is going to be 1, which has every element, distinct. So if you see all the GCDs obtained are distinct. But if you look at this 18, 6, 24, 18 has a GCD of 18, 18, 6 has a GCD of 6, so you write 6. 18, 6, 24 has a GCD of 6 as well, so you write 6. Now this subarray has two occurrences of 6, thereby this is not distinct, so I can say that this subarray is not a good, or whatever they are calling it, it's not a good subarray, whereas this subarray is a good subarray, because if you write the prefix GCD is पहले GCD of 15, then GCD of 15 6, then GCD of 15 6 and 19. So this is the entire prefix GCD. All of them are distinct. Got it? So I need the number of good subarrays. Yes, I need the number of good subarrays. For an example, let's take this example 18 6 24 1. 18 6 24 1. Let me give you an explanation. Okay, 18 6 24 1 को लेके explain करते हैं जिनको नहीं समझ में आया. So if I try to write something, see, we have 18 6 24. By the way, I'm explaining in English, not in C++ or Java. Okay, so please hear the explanation instead of thinking C++ and Java. So if I ask you which is the first subarray, the first subarray is 18. So the GCD of 18 is 18. Perfect. If I ask you which is the next subarray, this. What is the GCD of 18 and 6? The GCD of 18 and 6 is 6. So I got one more distinct good subarray. If I ask you what is the GCD of 18, 6, and 24, you basically get 6. Till here it was 18, till here it was 6. Now you got another 6. Now what I can say is this is no more, yes, this is no more a distinct one, because 6 you have already got. So I cannot say this is a valid distinct subarray. And if you go beyond, obviously that will also not be a valid one, because you already have two occurrences of 6. So what you can say is, starting with 18, you could only get two good subarrays. One was 18 and the other one was 18 and 6. So there are two good subarrays starting with 18. If you take 24, that will be a wrong stuff. If I start with 6, I will have 6 as the GCD. If I start with 624, then I'll have 6 comma 6 as the prefix GCD array, which will not be valid, because it has two occurrences of 6. Thereby I can say 6 is the only good subarray. 6 is the only good subarray, right? Now what I can say is, okay, fine, that is done. Next I'll go and start with 24. So if I start with 24, I know the GCD is 24, so that can be a valid good subarray. So if I take 24 and 1, I'll still have 24 as the first GCD and the second prefix GCD as 1. So I can say 24 comma 1 can be another good subarray. Yes, 24 comma 1 can be another good subarray. So thereby I will take 24 comma 1. Next good subarray can start with 1, and the I can say the GCD will be 1 of the prefix. Thereby 1 is a good subarray. So as of now, if you see carefully, I got 1, 2, 3, 4, 5, 6. I got 6 good subarrays. I got 6 good subarrays. Did I get 6 good subarrays or not? I did get 6 good subarrays, right? So how do you count this? So let me first explain you the simple brute force. So you saw that first subarray started with 18, then you took first 18, then you took 6, then you took 24, then you took 1, right? So can I say I can always start with 18, then I can always start with 6, then I can expand, then I can expand, then I can always start with 24. So I know one thing, I will always start with the first guy as 0, and then I can go on to take 6, 24, 1 as the first guys. So the I will always start from 0. Now when I starts from 0, can I say the subarray? First time the subarray, first time the subarray will be 18, then it will be 18, 6, then it will be 18, 6, 24. So thereby it will start from I itself, basic subarray logic. So this is how you can say the subarrays will be generated. This is how you can say, and the subarray will always be from I to j. The subarray will always be from I to j. First time it will be 18, next time it will be 18 to 6, next time 18 to 24, next time 18 to 1. At the next iteration of I, it will become 1. So it will be like 6, 6 to 24, 6, 24, 1. So did you guys, did you understand the generation of subarrays? So guys, did you understand the generation of subarrays? So this is how the generation of subarrays can be done. So can I say I can keep a GCD because I need the GCD to be prefix GCD. So can I say the initial GCD that I can keep is somewhere, like I can keep it as 0. For an example, I can keep it as 0. And when I start off, yes, when I start off, I can simply say that, hey, listen, since I am looking for the GCD, I can go and find the GCD of this guy, GCD, like underscore underscore GCD, comma, array of j, right? Just a sliding window, because every time there's a new element added, we have to update the GCD. We have to update the GCD, and we just need to take care that this GCD which is generated, if it's a duplicate, then this cannot be a good subarray. So probably you can use something as a set data structure. Set data structure in C++ Java. In Java, it is a hash set. So you can use a set data structure, and you can just check if the GCD which is generated, which is the new GCD for the new prefix, does it appear in the set. If it does appear in the set, then you can simply break out, or else you can do a counter plus plus. Got it? Got it, everyone? Has everyone got this? Has everyone got this? What I'm trying to say? You just keep on sliding window, right? Otherwise, you just break out. If it appears not, it will not give you a TLE, I'll tell you, because the break condition will always be executed very, very soon. The break condition will always be executed very, very soon. This might look like an n square solution. This might look like an n square solution, but it isn't an n square solution, because you cannot have repetitive, like you cannot have distinct GCDs for n length. That is not possible. Okay, that is not possible. It is not an n square solution, because the break condition will appear very, very soon, and I will explain you why. Anyone who's saying me to explain again, you have to get your basics right. How to generate subarrays, you have to know. That is a prerequisite. How to print all subarrays is a prerequisite to solve this problem. Print all subarrays. If you don't know how to print all subarrays, I think you need to go back and watch it. TLE won't be there. There won't be any TLE. There won't be any TLE. I'll explain you. If you take initial GCD as 0, GCD of 0 comma something will always be the number itself, if you know GCD's logic or code. So if I go back here, so very, very straightforward. I'll probably keep the counter to count the number of good subarrays, and I'll start off with I equal to 0, I lesser than n, I plus. By the way, in Java, for loop is written in similar way. Instead of set, you can use hash set if you are trying to do it. So what you can do is, okay, you can keep something like the GCD equal to 0 initially, then you can go as int j equal to I, j lesser than n, j plus plus, and you can say gc equal to underscore gcd of array of j comma gc to get the new prefix gc. And you can just look at if set has this guy. Yes, if the set has this guy. So this is how you write in C++. In Java, you can just do a map and you can just check it with a null. So that will be fine. So if this is not pointing to end, like, then this means it's a repetitive. It's a repetitive. You don't need to go ahead. And if it is, then if it's a distinct one, you do a counter plus plus. And at the end of the day, you can say you will return the counter. At the end of the day, you can say you will return the counter. In Java, you just have to do a null check over here on the hash set. That's it. And mat.gcd over here, mat.gcd over here. That's the only difference that you will have to do in Java. Okay, contains or whatever, you have to just check for null, and this will be mat.gcd. Okay. Oh, by the way, we got a wrong answer. Why did we get a wrong answer? Let's quickly have a check. Okay, we were, oh, forgot. My bad. insert ही नहीं कर रहा हूँ, देख रहे हो? भाई महान इंसान हूँ मैं. Yeah. Okay. So if you submit this, this will work fine. Now you might argue that Striver, this is an n square log n solution. This might look like, you need to understand, this might look like an n square log n solution, but if you sit back and think practically, you cannot have an array like this. You cannot हाँ लिखूँ मैं, जगह भी नहीं दे रहे. You cannot have an array like this, like 1 comma 2 comma 3 comma 4 comma 5 comma 6. You cannot have, because if you have, then the gcd of 1 and 2 will be 1, and the moment you try to add 3, the gcd will still remain as 1, and it will break out. For the gcd to be distinct, it has to be divisible. You need to understand, it has to be divisible by the new number or something like that. Like, assuming this is 2 over here, you can keep 4 over here, but then at the next time you cannot keep something like 5 and then 6, because the gcd till 2 will be 2, and the moment you add 4, the gcd will be again 2. So you need to be very careful while you are adding up, like the numbers increase. While the numbers increase, you have to be very, very, like, you will never be running, because every time you need the gcd to be distinct, it has to be divisible by one of the previous numbers. Otherwise it is not practically possible, right? It is not practically possible, because if you keep like 4, then you need to understand this is 2 and the gcd will still be 2, and you will get repetition. So this has to be something which is different, right? Something like a, let's say, what can I keep, uh let's say you keep 5 over here, and then, or let's say you keep 10, and then let's say you have to, this is the gcd is 10, and this has to be something like, let's say, 2. Then you get something like 2, but going forward you cannot keep something like a 4, because then the gcd will be again repeated to be 2. So you have to keep something which is kind of dividing these guys. So this is why the break condition will always appear very fast, because the constraints are very less, like 10 to the power 9. So the number has to be divisible. So you cannot have a plethora of numbers till which you will get distinct. So this break condition will always appear, very soon. Like, I cannot prove it mathematically. It's just a simple observation. I cannot prove it mathematically, because if you go to prove it mathematically, you'll require very high advanced. It's a very simple observation that you cannot have consecutive numbers, and you can't expect this loop to keep on running. It's a very simple observation. I am not sure of any other approach. It's a very straightforward approach that this loop will never run for very long distance. Cool. Has everyone understood this? Can I get a yes? So if you go logically, since the arrays can be of 10 to the power 9, so if you're dividing, it will be like, at max it will go till like logarithmic of 10 to the power 9. At max it will go till like logarithmic of 10 to the power 9 if you want all the distinct guys. ये सब कॉमन ऑब्जर्वेशन, यू डोंट नीड टू प्रैक्टिस दिस, दीज आर वेरी बेसिक ऑब्जर्वेशन. सो इफ यू जस्ट सिट बैक एंड थिंक, यू विल लाइक हाँ यार सही है. मतलब लॉजिकली सोचेंगे तो कितना ही दूर मैं प्रोड्यूस कर पाऊंगा नंबर्स, unless until everyone divides, like unless until I have something like this. If I given something like this, 64, 32, 16, 8, 4, 2 and 1, then this will have all distinct. Just see, for the first time it will have 64, then the GCD will be 32, then the GCD will be 16, then the GCD will be 8, then 4, then 2, then 1. In this way I can say logically it makes sense, because everyone is getting divided, so the GCD will be changing. So at max, since it is 10 to the power 9, to have the longest one, I'll have 10 to the power 9, then someone who divides 10 to the power 9, then someone who divides that, then someone who divides that, and so on, right? So that the GCD will always be distinct. That is where logarithmic of it. That's why logarithmic of it, because 10 to the power 9, then someone who divides 10 to the power 9, then someone who divides that, then someone who divides that, then someone who divides that. In order to get the longest, If you see, I took 64 and then I wrote someone 32 who divides 64. Then I could get the longest till which it will not break. So that's a 10 to the power 9, someone who divides 10 to the power 9, someone who divides. Got it? Got it, everyone? जावा में math.gcd था ना? जावा में math.gcd है. पाइथन में तो जावा में भी था शायद. ठीक है. है तो बिग इंटीजर पे. कोई नहीं, लिख लेना यार. जीसीडी का कोड नहीं लिख सकते क्या? जीसीडी का कोड खुद लिखो यार. बप बप बप. हो गया सबको समझ में? आ गया सबको समझ? Can I get a US from everyone? I do not use C++ at Google. I use Java and Angular. Like my tech stack is Angular, TypeScript, and these things at front end, and back end I use Java. C++, yeah, there are teams who use C++. Trust me, the C++ that you use in college is not the C++ that Google uses. It's way beyond that. So when you read the code base in Google about C++, you'll be like, "ये C++ ही है ना?" वो वाली फीलिंग आती है. जीरो कहाँ ले रहे हैं? जीसी हमेशा अपडेट हो जाएगा ना न्यू जीसीडी के साथ प्रीफिक्स बना रहे हो तो. Okay, let's go to the last question since everyone understood. Okay, I want you to read this question. How many of you were able to solve this? How many of you were able to solve this? How many of you were able to solve this? No, not Spring Boot. By the way, Google जो चीज़ें यूज़ करता है वो बाहर सदियों बाद आती है. जैसे गूगल पहले पूरा निचोड़ लेता है, यूज़ कर लेता है, फिर वो रिलीज़ करता है. तो whatever we use that's not in the market, that will come into the market after 5-6 years. Something like a protobuf. I'm not sure. अभी कुछ लॉन्च हुआ है protobuf. ठीक है, अगर तुम ये सर्च करोगे protobuf बोल की एक चीज़ है, तो Google has been using this for like 8 to 10 years now, and now they got bored of it. They got something new, so they released it into the market. And most of the frameworks that Google releases, they use it internally for a very long time, and then they are like, okay, now we need to move on, so let the world use it. No, I came here and I did learn Angular. I during my stint at Amazon and Media.net, I was a Java guy, so I did a lot of backend. But I wanted something which had front end, because so that I could use that knowledge in my website as well. So I wanted a full stack role. That's why I told my recruiter that please map me to a team which uses full stack. So I came here, and then I had to spend like 3 months to a stuff to learn Angular. But yeah, with time I got used to it. Now I'm pretty much used to it. I work with Java and Coliseum framework. It's not outside, as I said. You'll not understand. Why not React? अरे गूगल से आके पूछो, मेरे से क्यों पूछ रहे हो? अपन तो एक छोटे मोटे एम्प्लॉय है. अपन एक छोटे मोटे एम्प्लॉय है. गो बहुत यूज होता है. देयर इज दिस गो व्हिच गूगल यूजेस अ लॉट. काफ़ी सारी चीज़ें गो में लिखे हुए हैं, तो गो काफ़ी यूज़ करता है. I think going forward, 10 years down the line, Go will be used very widely across the industry. Along like Java is definitely going to be there because uh, people might say कि नया लैंग्वेज आ गया, अब ये चल रहा है, ट्रेंडिंग है. जितना भी ट्रेंड हो, जितने भी एग्जिस्टिंग कंपनीज है, बहुत मिलियंस ऑफ लाइंस ऑफ बिलियंस ऑफ लाइंस ऑफ कोड बेस है. कोई बैठ के पूरा नहीं करने वाला चेंज. एंड सॉफ्टवेयर डेवलपमेंट में एक चीज़ है, व्हेन थिंग्स आर वर्किंग, डू नॉट टच इट. तो जब चीज़ें चल रही है तो मुझे नहीं लगता अनलेस अंटिल कुछ मेजर इश्यू आए तभी जाके पीपल विल शिफ्ट फ्रॉम जावा. अदरवाइज द बिग कंपनीज व्हिच हैव बिलियंस ऑफ लाइंस ऑफ कोड इन जावा, दे आर नॉट गोना शिफ्ट. नया चीज़ें भले ही गो में बनाएंगे, बट जो पुराने चीज़ें वो जावा पे ही चलेंगी. I don't think Python is, not sure. I haven't seen that being used that much. Go and Java and Angular is used primarily. I'll talk about that in some other day. Let's get back to the question. So, given a tree of n nodes rooted at node one, the tree is given in form of an array where pi denotes the parent of the ith node. Also, pi equal to one as the root node. So, whoever is minus one will be the root node. Okay, you need to assign non-negative values. Remember this, non-negative. So you cannot assign non-negative values to each node of the tree in a manner such that it follows the following condition. Let A denote the value assigned to a node and B represent the sum of values assigned to the children of a node. So B is basically, if there are children's, you sum up them, that's B. The value is assigned to that. Now you need to make sure that whatever value is on the node, and that should be greater than equal to the values, the summation of the children. You're also given an integer x. You need to assign values in such a way that their sum is greater than or equal to x. Okay. So find the minimum value which needs to be assigned to the root of the tree. So for an example, this is the tree 1, 2, 3, 4. So they're saying total sum, assign it in such a way the total sum should not be lesser than 7. Should not be lesser than 7. It can go beyond 7, it can be 7, but should not be lesser than 7. Okay, so what they did was they assigned it something like 2, give it 2, give it 2, give it 1. So they were able to assign it. Now if you see, 2 is greater than equal to 2, so the condition is satisfied. 2 is greater than equal to 2, the condition is satisfied. 2 is greater than equal to 1, the condition is satisfied. Got it? So I can say that the root, if I assign 2 to the root, then I can have the total summation as 7 and it will work. Now you might say, striver, why not 1? Why not 1? See, if I assign 1, this guy cannot be 2, this guy has to be 1, this guy has to be 1, this guy has to be 1, right? So let me just draw this. So why not 1? Let's understand why not 1. Okay, so if I say this is 1, this is 2, this is 3, this is 4. So if I assign this guy to be 1, if I assign this guy to be 1, I have to assign this guy 1 because the condition states whatever guy is over there, it should be greater than equal to. It should be greater than equal to. So I can't assign 2 because then the condition will be void. The condition says root value should be greater than the sum of children. The root value should be greater than the sum of children, right? So you cannot assign like something like 2 over here. You have to assign something like 1, and again over here 1, again over here 1. So the total summation, if you see, it'll be 4, but they've clearly stated that you have to make sure that the summation is 7, right? Now can you assign 7? Can you assign 3 to the root? Yes, you can. You can have something like 3, and you'll be like, okay, I'll keep this as 1, I'll keep this as 1, I'll keep this as 1. So the summation is now 3, 4, 5, 6. That's not what they wanted. They wanted 7. So really you can just do a slight fix and you can say, okay, 3, 2, 1 and 1. This is valid. This is valid because they wanted x to be 7 and the summation turns out to be 7. This is valid. So you can actually assign the root to be 3 and that will be a valid solution. You can actually assign the root to be 3 and that will be a valid solution. But what they wanted is They always wanted you to find the minimum value. If you see, they wanted to find the minimum value. So instead of 2, I'll say I'll assign 2, this one I'll assign 2, this one I'll assign 2, this one I'll assign 1. In this way, the summation will be 7, and the root node assignation will be very, very minimal. The root node assignation will be very, very minimal, right? So thereby the answer comes out to be 2, right? So perfect. So you understood this. Now let's take the next example and try to understand it properly. So the next example has like 1 2 4 3 and x is 10. Okay, 1 2 4 3 and x is 10. It has 1 2 4 3 and x is 10. Okay, so now you want to keep the x as 10. So let's try assigning 1. So if I assign this guy 1, I have to make sure the summation of the children's have to be 1. So I have to assign in such a way that the summation is 1. Probably you can keep something like 0 1, or you can have something like 1 0. That's your choice. But however you assign, the summation has to be 1. This guy also has to be 1 because you cannot assign it like 2. So the total summation that you get is 3. But I wanted like something like 10. So that's not practically possible. So I'll just increase the value and try to assign it. So I can be like, okay, let's assign this 2. Let us assign this 2. Then since I want to reach 10, I'll try to assign as much as possible. So I'll be like, okay, I'll also assign a 2 to this, something like a 1 1. I cannot assign more than 2 because this has to be greater than this. Then I'll be like, let's assign 2 to this. So the summation now becomes 6. So the summation now becomes 6, which is kind of not done because we want 10 to be there. I'll be like, okay, let's assign 3. So if I assign 3, I will have to assign 3 over here because I cannot assign something more than 3. So I can either go like 1 2 0 3, which in whichever you way you'll feel like. So I can be like, okay, hey, listen, I probably will go like 3 0. Why will I go 3 0? Because I need this guy to be 3. So I'll go like 3 0. I'll go like 3 0 because I need this guy to be 3 as well. So as of now, if you see, the summation is 3 3 6 9. We haven't yet reached 10. So 3 is also not an answer. 3 is not an answer. I'll try to assign 4. Okay, then I'll try to assign 4 to this level as well, and 4 to this level as well, right? So I can definitely give it a 4, and I can definitely give it a 0. I can definitely give it a 4, and I can definitely give it a 0. So as of now, the summation becomes 12, which is greater than x. So if I assign 4, I can actually go more than 10. I can actually go more than 10. So I'm like, okay, if I assign 4, I can actually go more than 10. So I'll be a bit cautious and I'll try to assign lesser values. So I'll be like, okay, 4, 3, when I go 3, 0, and a 3 here. This gives me exactly 10, which is perfect. But I'm not concerned about how I'm assigning the children's. I'm more concerned about what is the value over here, and that is what they want. That is what they want. If you carefully see, 4 is what they want. 4 is what they want. They don't want anything else. So I know the answer is 4. I know the answer is 4. I know the answer is 4. So did you observe a pattern? Did you observe a pattern? Can I say, whatever you are assigning here, multiplied with the height, multiplied with the height should be greater than x. Can I see this? If I'm assigning 4, 4 into 3, that's 12, should be greater than 10. Then 4 is possible. If I was assigning 3, then at max I can go 3, 3, 3, 3, 3. So 3 into 3 is 9, so 3 is not possible. Can I say whatever I assign to the root node, that should be greater than equal to 10? Whatever I assign to the root node, that should be greater than equal to 10. Can I say this? Can I say this? Does everyone agree on this? Does everyone agree on this? Can I get a US if you agree? Uh, yes, Liko. Yes, yes, yes. Comments me, yes, Liko. I went slow and steady. No, no, yes, okay. You don't need to try all elements. See, no matter what you do, if there's a tree and they split across branches, if you're assigning someone to be like, let's say a value like whatever value you're doing it as x, the best thing you can do is you can also give it x. Whatever children is, the best thing is you can split x in some other way, right? So children can have more than x, doesn't matter. You give them, you just assign. So that's the best thing that I can do. I'm saying that's the best thing you can do, right? So if that's the best thing you can do, can I say this? By the way, have they mentioned that which kind of tree is this? Oh, it's a normal tree. Okay, fine. So can I say this? Then I'll always be able to split it in such a way, because I know I'll always get the answer no matter what I do, because I will always be able to split it in x ways. So I'll always get my answer. So can I say आंसर विल बी वेरी सिंपल. अगर मैं 3 into 3 हाइट किया तो 9 आया था, लेकिन 4 into 3 किया तो 12 आया, विच वॉज ग्रेटर देन x इक्वल टू 10. कैन आई से द आंसर इज 10/3 of seal. Can I say 10/3 of seal? Can I say the answer is 10/3 of seal? Can I say अरे बॉयकॉट बॉलीवुड, पढ़ाई कर. ट्विटर पे बॉयकॉट बॉलीवुड लिखने से तेरा घर नहीं चलने वाला, तो पढ़ाई कर भाई. Did you guys understand this? Because I know 3 into 3 will be 9, so 3 is not possible. So whatever is the height of the tree, I'll try to go like total divided by 3, so that, and the seal, so that it's possible. But if a children have one, children have three children in the terminal, it will always have. It will always have. Doesn't matter how it will always have, because you're concerned about the sum, not the individual values. You're concerned about the sum, not the individual values. Assume you want to give 4. I'll be like, okay, I'll give this guy 4. I'll give this 4. I'll give this 0, 0, 0. Right? And if this guy has like 3 stuffs, I just need to make sure that if this is 4, this somewhat like 1, 1, 1. It can go like anything. So it will always be possible. Right? It will always be possible. Just try to take some examples. It will always be possible. 10/3 is not the answer, because तुम्हें पता है अगर तुम 3 देते, मतलब 3 हाइट है, तो भाई 10/3 3 पॉइंट समथिंग है, तो 3 दोगे तो नहीं चलेगा, क्योंकि वो बोल रहा है कि भाई मेरा हाइट 3 है, तेरे पास 10 है देने के लिए, तो तुझे 3 पॉइंट सब कुछ देना पड़ेगा सारे हाइट्स को. तो भाई 3 दोगे तो चलेगा तो नहीं, 3 दोगे तो कम पड़ जाएगा. 3 पॉइंट समथिंग है, 3 दोगे तो कम पड़ जाएगा, तो अपन को 3 से ज्यादा देना होगा. एंड सिंस इंटीजर बोला है, तो 3 से ज्यादा अपन क्या मिलेगा, 4, which is nothing but x by height seal. X by height seal, right? Right? समझ में आया? आ गया समझ? Yeah, ceiling of 3.33. परफेक्ट समझ में आ गया? बहुत सही. हाइट ऑफ द ट्री निकालना सिखाना पड़ेगा. At least this program you can write in Java. मैं परेशान हो गया भाई, परेशान हो गया हूँ मैं जिंदगी से. एरे लिस्ट बना लो, ग्राफ बना लो, हाइट निकाल लो, डीएफएस, क्या बड़ा चीज है. प्राइवेट in Java you write private void, not colon. You write in Java, you write this. Okay. In C++ you write this. In Java int node is same. Okay. And we carry the adjacency list, and we will have the visited array. In Java adjacency list की जगह array list होगा, array list of adjacency, array list of adjacency. Visited of node equal to 1, right? This will be for of auto of it of adjacency of node. In Java it will be for of int I on adjacency dot get of node. This will be in Java. Okay, this will be in Java. This will be if not visited of it. This is a simple DFS. I'm doing the DFS on the tree. Then you say, okay, DFS of it adjacency visited, right? So this will be the DFS. Now you need to compute the height. So really you can just pass on a variable like height, and you can always increase the height as you go in the depth of the tree. And over here you need to keep a max variable. So you can either declare it globally, or you can just take it over here. C plus Java में तो normal, if you take a variable it will work. In Java में you can just declare an array of size 1, and you can pass that array and you can store it in 0 index. So you need to compute the max How can you compute the max? Let's do one thing. Let's create a height array. I forgot how to pass by reference, but ठीक है कोई नहीं. Java use करते करते Java का आदत हो गया है अपन को. Height of okay, visitor of node you can write height plus one plus we need we can omit this as well. Let's omit depth and let's do it over here. So what you'll do is visit is done, and over here whenever you go to this guy, just go to height of it will always be height of your node plus one. Super simple. Super simple. So by the way, this is in Java, this is in C++. C++ में भी array ले सकते हो, but I prefer vectors. So yeah, this is something again. This will be a Java वाले बहुत confuse करे. Okay, done. Vector visitor done. Vector height done. Everything done. So once you are almost ready, now just you'll take this P, create your graph. Create your graph. So create your tree. So tree creation is very easy. Use a vector of int adjacency of n to 1 based indexing it, 2 based indexing it. Just give it a check. It's a 0 based indexing, so it should be fine. Store the root. So as of now, you can keep this root as this. Auto of id of p. If it is equal to -1, that's the root of the tree. Else what it is saying, कौन किसका बाप है, denotes the parent of the ith node. Oh, ith node पे जाना होगा, ठीक है. So adjacency of I dot push back P of I, adjacency of P of I dot push back I. So this is how you can easily create your tree. For Java people, you just need to take array list of array list, and you need to do dot get of I dot add of P of I. That's it. Cool. So once you have created this particular thing, what is the next thing you'll do? You will call the DFS with the root, because that's the root. Then you will pass on a adjacency list. So pass on the adjacency list, then you'll pass on the visitor, then you'll pass on the height. Perfect. So declare vector of int visited n comma 0, vector of int height n comma 0. Perfect. Now you need the maximum depth of the tree, which is the height. So depth can be set as star max element, and in height begin height end. You do this. Once you have done this, what is your answer? The seal of this. So answer will be, this is how you find seal, x by depth. So x plus depth minus 1. This is one of the ways in which you can always find the seal depth, and you can return the answers. Or you can write the seal, you can use the seal function as well, you can use the modulus as well. So this is one of the ways in which you can find seal as well. Numerator plus denominator minus 1. चंदाने क्या हो गया भाई तुझे? Optimal IT was not declared in the scope. Oh, by the way, sorry. Depth will be +1. My bad. Depth will be plus. Yes. What you can do is, before calling the DFS, make sure the depth of the root is 1, because otherwise it will be wrong. ठीक है. अरे कंपाइलेशन क्यों आ गया यार? So how many of you got this? Your output is 7. Is output to 7 नहीं आना चाहिए. अब उन्हें आंसर क्या चाहिए था? X plus depth minus 1. What did the depth came in as? The depth. Did we compute the depth to be wrong? Not visited ID. IT address a node. Oh my bad. Height of node plus 1. That is perfect. DFS करके आओ. Height of node से जाओ. सही तो था. क्या गलती हो गया देखते हैं. हाइट ऑफ द ट्रीज 1 है. ओ भाई क्यों यहाँ कुछ गलती किए होंगे हम लोग. Root is equal to I, square of the root. See what is the root? Did it root came out to be 0. सही है. 0 को दे दिया मैंने. 0 पे डिफेंस मारेंगे. एडजेसेंसी ऑफ आई को पुश बैक किए पी आई पे. सही तो था ये. आई पे पी आई जाएगा. सही है. पी आई पे आई जाएगा. ट्री भी सही बना है. डिफेंस का नहीं चला. यहाँ पे ऐड डिफेंस. See, did you guys see anything? Mark visited note. मार्क तो किया है यार. नहीं कुछ और. यहाँ पे कभी आ ही नहीं रहा है. क्यों भाई क्यों नहीं आ रहा है? क्यों नहीं आ रहा है यहाँ पे? ID of adjacency of node. It never came here. Oh goodness, it never came here. Okay, let me see what is the mistake that we did. Just give me a second. You guys, notes are one based. Are you sure the notes are one based? Are you sure the notes are one based? I don't think. Oh, they are. No, N is 4. The node one based. Let me see. तो 0 पे कुछ है ही नहीं. हाँ नोड आर वन बेस्ड. एग्जैक्टली नोड आर वन बेस्ड. स्कैम हो गया मेरे साथ तो. Scam. Node are one based. Yes, the node are one based. Segmentation fault. Yes, I got segmentation fault. Cool, चल गया. The nodes were one based, so we had an issue. Yeah, should be fine now. No, root is not. ठीक है जो भी है छोड़ो. So is the root minus 1 always? अरे अभी तो इस पे चेक किया था. चल तो रहा था. Its correct output is 2. Oh, my bad. X plus depth 3. 7 plus 3, 10. Minus 1, 9. Height 3 थी. इसकी हाइट कितनी है? 4 है इसकी हाइट. हाइट इसकी 4 है. तो डेप्थ 3 क्यों आया? 1 2 3 4. 4 कहाँ से आ गई? 4 तो था ही नहीं इधर. अच्छा बेटा 1 2 3 बोल रहे. 4 का पैरेंट 3 है. आई प्लस 1 4 पे गया. पैरेंट को पुश किया 3. हाइट गलत निकल रही है. Just remove adjacency list. No, why will I remove adjacency list? It should be fine. I'm looking at something else. Give me a second. Root is 1, height is 1. I get the maximum element. This is fine, but why is it not going across this one? डेप्थ सही क्यों नहीं? अरे ग्राफ सही नहीं बन रहा है इसीलिए। ग्राफ नहीं है, ट्री है। नॉट अ ग्राफ, इट्स अ ट्री। ओ 3 इज 4 का पेरेंट 3 है, तो यहाँ पे जो बंदा है 3 के पेरेंट पे पुश बैक who's the children of 3, who's the children of 3, so 3 का children, who's the children of 3, 4, yeah, perfect. 3 का children is 4, अभी भी 3 आ रहा है, what the hell, PI कौन है? 3 है, 3 को बोल रहा हूँ डोंट लिसन, 0 1 2 3 4 है तेरा पेरेंट। Yeah, we can move it. I'm just keeping visited just as a safety. Should work. Ideally should work. Let's see if the graph is formed. Let's see if the graph is formed correctly or not. Just give me a second. I think the graph formation has an issue. Let me just see the graph formation once. 1 का 2 है, 2 पे जाएगा, 2 का +1 मार्क करेगा क्या? हेड ऑफ नोड +1 मार्क करेगा। नोड क्या दे रहे हैं हम लोग? रूट दे रहे हैं। रूट कितना है देख लो एक बार। थ्री का पेरेंट 4 है, 1 का पेरेंट 2 है, 2 का पेरेंट 3 है, 3 पे गया, सही तो है। Oh my bad. One based indexing. Thank you so much. हाँ, ये 1 0 वेस्ट हट। Anyways, thank you so much. Yeah, size is the height. Size is the height was an issue. Yeah. कोई नहीं, कोई नहीं. We competitive programmers have this habit of doing ना. हमने फिर do this. मैं तो ऐसे करता था हमेशा. I always used to define everything like maximum constraint plus 5. हाँ मतलब ठीक है, रूट अगर हमेशा 1 है तो 1 से कर लो, कोई बात नहीं। लॉजिक समझ में आ गया ना? लॉजिक समझ में आ गया ना? वो इम्पोर्टेंट था। लॉजिक समझ में आ गया ना? वो इम्पोर्टेंट था। एनीवेज, डिड यू गाइस गॉट इट? क्या है इसमें कोड में सेल्फ एक्सप्लेनेटरी है डूड। दिस इज हाउ टू फाइंड द हाइट ऑफ अ ट्री। इफ यू डोंट नो हाउ टू फाइंड द हाइट ऑफ अ ट्री देन आई कांट एक्सप्लेन। हाइट ऑफ अ ट्री में क्या पढ़ा हूं? यू कैन जस्ट गो अक्रॉस एंड फाइंड इट हाइट ऑफ द ट्री। बच्चा वाला है। The issue was nothing. The issue was it was one based indexing. I was coding for zero based indexing. So the definition over here was n. So it was not storing the height. Yeah. Cool. Has everyone got it? Has everyone got it? So I'll just end the stream. Can I get a yes from everyone if everyone has got this? If everyone has got this, can I end the stream? अरे जिसको एक्सप्लेन अगेन बोलो, पीछे जाके देख लो ना यूट्यूब में। एक अच्छा सा फीचर है ड्रैग करके पीछे जाने का। जितने लोग बोलते हैं ना एक्सप्लेन अगेन, यूट्यूब हैज गिवन सच अ वंडरफुल फीचर, ड्रैग बैक, लिसन इट अगेन। Which keyboard do I use? I use this wonderful Patlusa keyboard. It's very good. Okay, guys. So ये गोरू छागल में समझ गया, ये आया है फेक अकाउंट बना के। नाम तो सही रख लेता है डूड। जब Okay, cool. So we will be ending the stream for today. We'll meet in the next probably Job-A-Thon. Next Job-A-Thon is when we'll meet, and after that, let's see when we meet again. So that's it for today, guys. I hope you enjoyed the stream. Just in case you did, please hit that like button. If you haven't checked out the new one launched Striver's A to Z course, you can check it out on my channel Striver. You can also subscribe to Take You Forward. My LinkedIn link is in the description. You can connect with me as well. With this, I'll be wrapping up this one. Just make sure you like it. And चलो मिलते हैं किसी और stream में. Till then, bye bye. Take care. Good night.